Hello students, it is the fifth video of the chapter motion. In the earlier videos, we have discussed about distance, displacement, speed, velocity, rest and motion, and distance time graph. In this video, we will discuss the acceleration and velocity time graph. Acceleration and velocity time graph. What is acceleration? The rate of change in velocity is called acceleration. The rate of change in velocity is called acceleration. Means when a train approaches towards the platform, its speed gradually decreases, and this rate of change in speed is called negative acceleration, because in this case the speed of train gradually decreases. On the other hand, when a train left the station, its speed gradually increases, and this is called positive acceleration. In this case, the rate of change in velocity gradually increases. Now, acceleration, the rate of change in velocity. The rate of change in velocity is called acceleration. Let a body start its motion with velocity u. And its velocity changes to v in time t. Let the body first start its motion with velocity u meter per second. Then its velocity changes to v meter per second in time t second. Then what is initial velocity? Initial velocity u. Final velocity v. Change in velocity. Final velocity minus initial velocity. What is final velocity? V. What is initial velocity? U. So change in velocity equal to V minus U. Now rate of change in velocity. Rate of change in velocity means change in velocity by time. Rate of change in velocity means how much velocity change in a unit time. In unit time, what is the change in velocity? That is the rate of change in velocity. Change in velocity we get v minus u, time t. But according to definition of acceleration, the rate of change in velocity is called acceleration. Therefore, acceleration a is equal to v minus u by t. If we multiply it, at is equal to v minus u, or v equal to u plus at, and this is also the first equation of motion. This is the first equation of motion. Now you understand what is acceleration? Now we will discuss the Vt graph. What we will discuss? Vt graph. In the previous video, we have discussed about dt graph. In the dt graph, how can we find velocity? And if the dt graph is parallel to time axis, the body is at rest. And if the dt graph is a straight line and inclined at an angle with time axis, then it is the, we will discuss vt graph. We will take time along x-axis in second and velocity in meter per second along y-axis. This is 1 second, 2 second, 3 second, 4 second, 5 second. This is 2 meter per second, 4 meter per second, 6 meter per second, 8 meter per second. If we draw the graph, let the graph be a straight line which is parallel to time axis. The graph is parallel to the time axis. From this graph, what we will know? At 1 second, the velocity of the body is 6 meter per second. At 2 seconds, velocity is same 6 meter per second. At 3 seconds, 6 meter per second. That means the speed of the body does not change with respect to time. The speed remains constant. Hence, the body travels with uniform motion. From this graph, we know if dt graph is parallel to the time axis, then motion of the body is uniform. As there is no change in velocity, velocity does not change, means change in velocity is 0, rate of change in velocity 0 by time equal to 0. That means here the acceleration of the body is 0. And the acceleration of the body is 0. Now we will discuss another case. Second case. We will take time in second along x-axis and velocity in meter per second along y-axis. Let at 1 second the velocity of the body is 5 meter per second. At 2 seconds, its velocity changes to 10. At 3 seconds, velocity changes to 15 meter per second. At 4 seconds, velocity changes to 20 meter per second. Here the graph is a straight line inclined at an angle with time axis. Inclined at an angle with the time axis. If we naming it as O, A and B, what do we know from this graph? The velocity of the body increases by equal amount in equal interval of time. From 1 to 2 seconds, it increases by 5. From 2 to 3 seconds, it also increases by 5. From 3 to 4 seconds, it also increases by 5. That means velocity of the body increases by equal amount in equal interval of time. Here, since the speed of the body does not remain constant, hence the body doesn't cover equal distance in equal interval of time. If the body doesn't cover equal distance in equal interval of time, then that is non-uniform motion. The motion of the body, if you write like this, if Vt graph is a straight line, inclined at an angle with time axis, then the motion of the body is non-uniform. To calculate the acceleration, what is the rate of change in velocity? We have to find out the slope. In the dt graph, I have told how to find slope. The distance in y-axis over the distance in x-axis. The slope of Vt graph represents acceleration. So acceleration is equal to slope y distance AB and x distance OB. AB by OB. This is 20 meter per second. This is 4 seconds. 20 by 4. 5 meter per second square. 5 meter per second square. And how can we know the distance covered by the body from the Vt graph? In this graph also, how can we find the distance? We will name it OABC. The area enclosed between the graph and the time axis. This is the time axis and this is the graph. Between this graph and time axis, the area, if we find, then it will represent the distance covered by the body. Area enclosed between the graph and time axis represents the distance covered by the body. Here in this graph, distance d is equal to area of OABC, and here OABC is the rectangle. What is the area of rectangle formula? Length into breadth, OC into OA. Length equal to 5 and breadth is equal to 6. 30 meter. In this graph distance, if we find area of triangle OAB represent the distance covered by the body. What is the area of triangle formula? Half base into height. This is the base and this is the altitude. Half base is the OB and height is the AB. Half OB is the 4 and AB is the 20. 2 to the 4, 40 meter. In this case, distance covered is 40 meter, and in this case, distance covered 30 meter. Now, you have to know these 2 points, that slope of the BT graph represents acceleration, and if we find the area covered between the graph and time axis, then we will get a distance covered by the body. Now, in this video, what we will discuss? What we discuss? Acceleration and 2 types of BT graph. 2 types of BT graph. In the acceleration, I have forgotten to told you that acceleration is the purely vector quantity and its unit is meter per second square. SI unit is meter per second square. In the next video, we will discuss the various equations of motion. If you like my teaching, then like, share and subscribe it. Thank you.